Section 1.6 in pre-calculus, and this is on page 15 of your packet. We are going to look at the inverse function. All right, we've got three methods for determining whether two functions are inverses of each other or not. The first method is to determine algebraically. Algebraically, what you would want to do is you find their compositions. So if you've got two functions, f of x and g of x, and you're asked to determine are they inverses of each other, if you do both compositions and they equal x, then they are inverses of each other. That x correlates to the line y equals x, which is the reflection line for graphs and their inverses. All right, second method is numerically, you're going to set up a table of values for f of x, where you just do input-output. So you do what x is, what f of x is. You do a few values, maybe like 0, 1, and 2. And then you do the same thing for a table for g of x. But you're going to take the y's and place them here. And what you're trying to do is see if the ordered pairs are just completely reversed. Okay? And our third method is graphically. You'll take both equations and you're going to graph them. You can use the zoom square window, and you want to see if the graphs reflect across the line y equals x. Here is your line y equals x. So as long as there's a mirror image across this line, then they are inverses of each other. So we've got three methods, and I would say typically you can use any of those methods, but it's pretty quick in order for us to use our graphing calculators. All right, we're going to practice all three. We've got our first example. F of x is 2x to the third minus 1. G of x cube root x plus 1 divided by 2. Are they inverses? Well, let's go ahead and do their compositions. So let's do f of g of x. This is equal to. So we're going to substitute. We go 2 parenthesis cube root x plus 1 over 2. Raise that to the third power minus 1. X plus 1 over 2, cube root of that to the third power. These are going to cancel each other out. So we've got 2 times x plus 1 over 2 minus 1. The 2's cancel. We're left with x plus 1 minus 1, which equals x. So far, so good. The first composition equals x. So we turn around and do the other composition. G of f of x. Cube root. You put 2x to the third in. Minus 1. That's in for x. Then you have your plus 1 all over 2. This equals cube root 2x to the third. If you add the 1 and negative 1 together, you get 0 over 2. This is equal to cube root, divide by 2, they cancel, x to the third. Cube root of x to the third is x. So yes, indeed, they are inverses of each other because we're showing both compositions equal x. Okay, numerically. Let's do a table of values. Let's do x and f of x first. So let's substitute 0 in. We're putting 0 in for x here. The output is negative 1. Let's put 1 in here for x. The output, 2 times 1 to the third is 1. So it's 2 minus 1 is 1. And we'll do one more value. Let's put in 2. So 2 times 2 cubed, 2 cubes, 8. That's 16 minus 1 is 15. So now what we're going to do is we're taking x and g of x, but I'm testing the points of negative 1, 1, and 15. And what we're going to show is that we will get the results of the first column here. Let's put negative 1 in. Now we are going to this expression. So negative 1 plus 1 is 0 divided by 2, 0. Cube root of 0 is 0. Putting 1 in here. 1 plus 1, 2 divided by 2 is 1. Cubed root of 1 is 1. And let's put in, oops, this was supposed to be a 15. Let's put in 15. 15 plus 1 is 16. The cube root of 16 over 2 is the cube root of 8, which is equal to 2. You can see that my columns are completely switched. My x's are my function's output, and my output here is my x values on the second column. So yes, they are inverses of each other. All right, graphically, what you're going to want to do is you're going to want to put them into your graphing calculator. And let's go ahead and do that. Go to your y equals. Why don't you go ahead and pause the video and put them into y equals 1 and 2, and we'll come back and I'll show you what the graphs look like. All right, here's what our graphs look like. The first one that we've got, the first one looks like this. Comes in, intersects at negative 1 and positive 1 here and back up. All right, and then we've got the graph here coming in, intersecting at negative 1, positive 1, just like that. So they do reflect each other. There's a reflection about the line y equals x. You can look at that. You want to make sure that you do the zoom square, because otherwise it's a little distorted if you use the zoom 6, which is typically what we go with. All right, so they're inverses. Those are the three methods. Some methods are a little easier than others. All right, the next thing that we're going to look at is the existence of an inverse function. The existence of an inverse function. First of all, you would have to have a function. Here's an example of a function, y equals x squared. Here's our parabola. This is a function. It passes the vertical line test. What we would want to do with this function is let's reflect the graph over y equals x. Let's reflect it. There's my line y equals x. So if I reflect it, it's going to look like this. All right, now look at this reflection. This is my original function, and now this is my reflection, so possibly my inverse. Okay. Is it a function? Is this one a function, yes or no? It is not. It fails the vertical line test, so this is not a function. All right, here's how you're going to be able to tell if your given equation has an inverse function. It's called the horizontal line test. If I were to take my original graph, my original parabola, and I run a horizontal line through it, you're testing to see if it's 1-to-1. You can see here that my horizontal line intersects the graph at more than one place. We got two different intersections. This indicates it is not 1-to-1. Okay? It's not 1-to-1. So if it's not 1-to-1, then it does not have an inverse function. They go hand in hand. Okay? So a one-to-one function is a function f. It is one-to-one if it passes the horizontal line test. If it does not pass the horizontal line test, then you do not have an inverse function. Statement here, algebraically, it's trying to tell us that if we do have a function and a and b are two different input values, but yet if we find that f of a is then equal to f of b, in order for it to be one-to-one, then a has to equal b. They have to be the same value, because we cannot have two different x values here, a and b, and get the same y value, because then it fails the horizontal test. If it fails the horizontal test, then the inverse of it is not a function. All right, let's go ahead and look at some examples, and we're just going to determine if we have an inverse function or not. So what about this one right here? What if I give you this graph? First question, is it a function? You have to determine if this is a function. You use the horizontal or the vertical line test. This is a function. Is it one-to-one? So you pass your horizontal line through it. It's not one-to-one. Therefore, not an inverse function. Does not have an inverse function. All right, let's look at another one. The cubic. Is it a function? It is a function. It is one-to-one. Therefore, it does have an inverse. It has an inverse function. But that's basically what you would look for. All right, the last thing that we're going to do is we are going to find the following inverses. We're going to use these steps to find the inverse. You want to know, first you have to have it to be a function and it to pass the horizontal line test to be able to get the inverse, okay? We are going to replace f of x with y. Okay, you want to pause the video here and write these steps down. Replace f of x with y, because normally we have f of x equals. So we want to write it as y equals. And then you're going to exchange the x and y, so switch places with them, and then solve for y. And then replace again, write it back into f inverse form. Finding the inverse. All right, here we go. We got a couple examples to do this. All right, going through my steps. First step, we're going to write it as y equals. And then you switch the x and y. Algebraically, we're going to solve for y. We're trying to isolate it. I'm going to do inverse operations. So square both sides, like this. You get x squared equals y minus 5. Last step, move the 5 over. Y equals x squared plus 5. Put it back into function notation. F inverse equals x squared, f inverse of x equals x squared plus 5. There's our answer, inverse of that problem. All right, next one, so we have y equals x minus 4 over x plus 2. Switch the x and y. X equals y minus 4 over y plus 2. We have to figure out how to get the y's on the same level and on the same side of my equation. The only way to get rid of this fraction is to treat this like a proportion, and we're going to cross multiply. So we've got x times y plus 2 equals y minus 4 times 1, which is y minus 4. Still trying to get the y's on the same side so we can isolate them. We are going to have to distribute that xy plus 2x equals y minus 4. We're going to rearrange our equation to put our y's on the left side, xy minus y plus 2x equals negative 4. Still got to try to isolate my y's. I'm going to move the 2x to the other side to get it out of the way. You've got xy minus y. None of these are like terms. You can't combine them unless they're like terms. Okay, bring out your y. You're going to factor the y out. You get left x minus 1. We finally have y all by itself. And your last step is to divide by x minus 1. So y equals, you got negative 2x minus 4 over x minus 1. So that's quite the process, and really the reason why we had to do all that is because in the very beginning we had a fraction, and then the variable that we were trying to solve for, that fraction was in the denominator. I'll show you here. This was a 1. This fraction was in the denominator, so we had to figure out how to get the y's together. Final step, f inverse of x equals negative 2x minus 4 all over x minus 1. So you might want to go back through here and review the solving, how we solved for y, how we're able to get it all by itself. You got to use some rearranging of the equations and factoring. That's it for inverses. This is your assignment.